Okay, Math 3. I figured I would go over the test real quick. The test will be Thursday, so I figured I'd go ahead and go over it with you real quick. The review will be tomorrow. So it says, what is the leading term of the polynomial? Remember, to find the leading term, you find the degree. Remember, the degree is simply the biggest exponent. Okay, so looking at this one, here's the biggest exponent. Okay, so that would actually be the leading term there. So your leading term would be x to the fifth. This basically terminology of polynomials. So really not a whole lot to it as long as you know what you're looking for. What is the leading coefficient of the polynomial f of x defined below? Once again, find the degree. The leading coefficient is just the coefficient in front of your leading term. That's my leading term since that's got the degree in it. So my leading coefficient is -9. All right. What is the degree? Remember, the degree is the biggest exponent. Also tells you how many solutions a polynomial has, whether to be real or imaginary. But the biggest exponent here is 4. Okay. So this is a fourth degree poly. Okay. What is the y-intercept? Remember, the y-intercept is always 0 and your constant. Well, the constant, of course, is a number without a variable. So the y-intercept of this polynomial is simply 0, -5. Just knowing what to look for on these is pretty much the answer. There's really not a whole lot of math to it. So those are pretty straightforward. Okay, number 5. Determine the domain in which the following function is increasing. Remember, increasing means the part that has a positive slope. All right, so looking at my slopes, this side of this function has a positive slope. So that means it is increasing on this side. All right. Well, now, if you look at this coordinate here, kind of like the vertex of this is kind of like a parabola. That is 32, which honestly the y value doesn't matter anyway. Okay, so now this thing is increasing from the y-axis, which is this guy here, got a closed circle, up to its vertex. Okay, so since it is increasing between two numbers, you know it's going to be this. All right. This is the y-intercept, so that's 0, 14. Really, the y don't matter. So since it is a closed circle, we're going to put it equal to. So this thing is increasing from an x value of 0 to an x value of 3. Since it is defined by a part of the function, that would be equal to as well. So that would be your interval of increase. Also, you could write it as this, in interval notation. I guess really you could, that doesn't have to be an equal to because it's not really doing anything at 3, but it's right, kind of like sitting flat. So probably would be better not to put that as equal to. That's just, it increases to the end. But I mean, I would mark it right either way, but just probably leave the equal to off of this side and make it just a rounded bracket. This needs to have a square bracket here. Okay. Determine the domain in which the following function is decreasing. Okay, so it's decreasing from this vertex here to this closed circle at 9. Okay, so it is decreasing here. Negative slope. Decreasing, of course, is a negative slope. Okay, so that being said, this thing is going to be decreasing between two numbers. So we got x. I'm going to leave this not equal to since it's not decreasing or increasing at 3. That's where it actually changes directions. So it's going to be it decreases from 3 to 9. 9 is a closed circle, so I'm going to put that as equal to. Or if you want to put in interval notation, it would be 3, close 9, square bracket. All right. Decreasing, remember, just negative slope. Always read your slope left to right, so don't forget that. Okay. All right. Determine the domain on which the following function is increasing. So we look for a positive slope once again. There's the x value of where it changes from increasing to decreasing. Okay, it is increasing on this side. Okay, it is increasing on that side. Positive slope. All right, now, so that being said, if it's increasing on the left side of this vertex, x value of that vertex there, I know since it's on the left side, the left arrow, the x values always go to, or less than, on the left side of your function. And the coordinate here is -1, +3. Y value doesn't matter. Okay, so where it's increasing is on the left side. Since the left arrow always starts with x less than, it's -1, or it could be -infinity to -1. Either one of those would work. All right. Now, determine the domain in which the following graph is positive. Okay, so positive means above the x-axis. Okay, anything above the x-axis. Okay, so that means this interval is positive. This interval is positive. Okay, so you're going to have two intervals here. All right. Now, since this is the left side, the left arrow of my function, just looking at left side, right side, I know the left side is a part of that interval, so I know it's x less than. All right. And the number where it stops being positive is at +1. So it's x less than 1. So any x value I plug in less than 1, it's going to have a positive y value. If this is the right arrow, that's x greater than. That's the right arrow, and this always goes together. And it started being positive at 5. Okay. So it would be those two intervals there. It may need an or in there. Maybe you may be able to add a solution. I'm not sure how the answer will look, but it would be both of those intervals. So make sure you have both of those. Okay. All right. Number 9. Determine the domain in which the following graph is negative. Negative means below the x-axis. Anything below the x-axis is negative. All right, there's a negative portion. There's a negative portion. All right, now, left side of the function, left arrow, just basically look at, this is the left side, this is the right side. We know that starts with x less than on the left side. We know this starts with x greater than on the right side. All right, now, looking up here where it started to become, where it stopped being negative was -4. It switched over to positive at -4. And then it kept positive between -4 and 0. And then it became negative again. So it's going to be, that number there is, of course, 0, the x value of 0. So any x value that's greater than 0 is going to have a negative y value because the graph is below the y-axis. So there's another one of those ors. Okay. All right. Determine the domain in which the following graph is positive. Once again, positive is above the x-axis. It's another one of those two-piece ors. Now, it is positive above the x-axis. It was above the x-axis till it got to 2. So remember, left side is x less than. Where it stopped being positive was 2. So there's that interval there. Any value I plug in less than 2, it's going to give me a positive y value, which is what we're looking for. All right. Now, it was negative between 2 and 6. So any number between 2 and 6 gives me a negative y value, which is not what we're looking for. Any number greater than 6 is going to once again give me a positive y value because it's above the x-axis. So since this being the right side, automatically you know it's going to start with x greater than. That's just always goes together. And then there's 6. Of course, I would have one of those ors in there. All right, so there's your domain of positive, negative. Let's see, let's keep going. Okay, the function f of x is graphed below. What is true about the graph on the interval x equals negative infinity to a? Okay, so x coming from negative infinity would be, you're coming from negative infinity from this direction. So this shows the part coming in from negative infinity. Okay, so this would be that part right there. Okay, because remember, this is in the x direction going to negative infinity. Okay, because even though it's going straight up, that means it's going to positive in the y direction, but it's coming from negative infinity in the left. And it's talking about from negative infinity to a, which is this piece right here. Well, we know this is positive because it's above the x-axis. Now, looking at it from left to right, coming in this way, always left to right on the slope. And when I come here, as soon as I get here, I start decreasing, right? I have a negative slope. So I'm looking for something that's positive and that's decreasing. So that would be option B, positive and decreasing. Positive above the x-axis, decreasing because it's got a negative slope left to right. Always left to right on their slope. All right. F of x is graphed below. What is true about the graph on the interval from D to E? D to E. That's just this little part right here. Okay. We know it's positive. It's above the x-axis, so it's positive. From left to right, it is actually decreasing there. So that's actually going to be the same answer as the last one. Decreasing, negative slope from left to right. It's positive because it's above the x-axis. Here's the x-axis. And it's above the x-axis, so we know it's positive. So that would actually be B, positive and decreasing. Okay. The function f of x is graphed below. What is true about the graph on the interval from point B to point C? So point B, point C. Well, first of all, this is below the x-axis, so that's negative. But from left to right, this is increasing. Okay, so from left to right, that is increasing. Has a positive slope. Okay, so that means it is increasing, and it's negative because it's below the x-axis. Okay, so that being said, if it's negative because it's below the x-axis, it's increasing from left to right because it's got a positive slope, then the answer would be C, negative and increasing. Okay, these are kind of the same problems, just these are a little more in depth because you have to actually write the intervals. Determine all intervals on which f of x is greater than or equal to 0. Notice you do have an equal to, so you would need an equal to in your answer. Now, remember, this means y values greater than or equal to 0 or positive or equal to 0. That's what that means. So remember, positive is above the x-axis, okay? It can touch, okay? It can touch. So that being said, coming in, you are in a positive territory coming in, okay? It touches here, but it goes back up, so it doesn't cross into negative territory. So it's still positive, positive, all the way till it gets to that x value is positive or equal to 0. So what that says, since this arrow is on the left, that means that it will be positive x less than equal to because it's equal to here. It is positive or equal to 0 for any x value that is less than or equal to where it crosses the x-axis in negative territory. So that would be -2. Or it could be negative infinity to -2 square bracket. Either one of those would work. All right. Next question. Determine all intervals on which the graph of f is increasing. Okay, so coming in, we are increasing here all the way till we get to -4. So we came in increasing. So that being said, since it's run off the left side of the graph, we know it's x less than, okay? And it's increasing until it gets to -4, okay? So there's one of my intervals. Now, it's decreasing here, okay? So it's decreasing because it's got a negative slope. So we know this is not what we're looking for. Once I get here, it does go back to an increased interval between those two x values. So you know that's going to be a compound. So that is 1, -5. This is 5, 3. Y values really don't matter. So my interval here would be compound. That's your answer. All right. So it is increasing between the x values of 1 and 5. 1 and 5. All right, this is decreasing and it goes off the graph here. So these would be the only two intervals you would have, these two right here that are increasing. Okay, number 16, determine all intervals on which the graph is decreasing. Looking for anything with a negative slope. All right, we're coming in with a positive slope, so that's not what we're looking for. Starting here, it starts to slowly decrease until it gets to here. So that's between two numbers. Okay, so that being said, this little piece right here, this decreasing, is between -3 and +2. Remember, those are x values. Okay, so there's that little piece right there. From -3 to +2. It's going to be a compound inequality because it's between two numbers. All right, and then it starts to increase here until it gets here once again. And then it decreases for just a couple x values here, which is from x value of 5 to an x value of 7. So that's between two numbers, so you know it's this. It started at 5 and it stopped at 7. So there's your interval there. All right, so it's decreasing. So you got two intervals, this interval and this interval. So you got two compounds because it's between two numbers. Okay. Number 17. The function f of x is graphed below. Circle all relative extrema. That means max, and min. If it's extrema, that means both. Okay. So that being said, there's a minimum. There's a maximum. Okay. So that's a relative relative min. And this is a relative max. So those two would be circled as being a relative min and a relative max. Since you're looking for extrema, that covers both max and min. Okay. The function f of x is graph below. Circle all relative minima. So we're looking for minimums here. Well, we got a max here. Here's a min. All right, so max, then a min. So there's one min. Here's a max. Then here's a min. Okay, so since you're looking for minima, which is plural for minimum, you have two of those. That's at point D and at point G. Point B is a max, point E is a max. So that would be, that ain't what really we're looking for there, okay? The function f of x is graph below, circle all relative minima. Well, only thing you have here is a relative max. That would actually be your absolute max too. So there is no mins. So it'd be none. All right. All right. And then, so you got that. So no minimums. All right, the next one's going to be those problems where you have to check all that apply. The given function f of x is defined on the interval -9 to 9. That just means the domain starts at -9 and stops at +9, and it's represented by the graph. For the circle point below, select all that apply. Okay, well, we know that it goes from an interval of decrease to an interval of increase. So that's a min. And plus it has a hump towards the bottom of the graph. We know that's a relative min. All right. That is not the absolute min because these are the absolute, this is the absolute min here, not that one. That one would not be. The relative, the absolute min here. So that would actually be the circle point is just a relative minimum. So that's it. Okay, the given function f of x is defined below on the interval of -9 to 9 and represented by the graph below. Find the x values for all local maxima. Okay, I see one local maxima, and that's here. Okay, so that is the coordinate 0, -2. Now they're wanting to know find the x values. Okay, so the only x value that has a local maxima is x equals 0. All right, so it goes from an interval of increase to an interval of decrease, so it does fit the criteria for relative maximum. So, and that's the only one. All right, the graph f of x is defined on the interval -9 to 9 and represented by the graph below. Find the x values for all local minima. There's a local minima. Here's a local minima. Okay, so the x values here as -4 because that coordinate there is -4, +4. Okay, so the y value doesn't matter here. Okay, and then this guy, this coordinate is 6, -3. So x equals 6 is the x value for the local minima there. So the two you would be looking for is x equals 6 and x equals -4. All right. Okay, 23. Determine the domain on the following graph. Just make sure, guys, this is your leftmost point. This looks like to be the rightmost point. Okay, so your domain there would be, you can write it a couple different ways. That's a closed circle. So you could do it -6 with a closed bracket. Now this is an open circle, so that's going to be an open bracket. That is an x value of 7. So it's going to be rounded parenthesis, or you could write it with an inequality, -6. It's going to be equal to, since it's closed, It's going to be open, or it's going to be less, not equal to since it's open. Either one of these would work. So any one of those would work. All right. So you're just looking for that. Remember, domain is just x values. Doesn't pertain to the y values here. So you're just trying to find out what x value it starts with and what x value ends with. Pretty simple problem. So shouldn't give you too much trouble there. Okay, determine the range. Guys, make sure that you try to find the highest point, whether it be an endpoint or not, and the lowest point, whether it be an endpoint or not. Well, here's the highest point here that I can see on the graph. That's -2, -1. And then here's the lowest point I see on the graph. That's 5, -8. Okay. So now we're looking for range. All right, so range is y values. So that being said, the x values here won't matter because since we're talking about range. All right, so a couple ways to write that here. That would be bracket -8. Remember, smallest number on the left. -1 bracket, because it's defined by a line, so it is equal to. Okay, or you could write it this way. -8. Make sure you put that as a y value because you're talking about range. So either one of those would work. It'll be sufficient. Okay. 25. Determine the domain of the following graph. Just looking for the leftmost point. Domain is, of course, x values. The leftmost point here is the coordinate -9, +9. The rightmost coordinate is -1, 0. Okay, y values don't matter because it's a domain. So this guy is going to be -9, -1, square bracket, or if you want to write an inequality notation, it's going to be -9. X value is less than or equal to -9. X value is less than or equal to -1. All right. Okay, going to the next problem. There's a lot of problems on here. Number 26. The polynomial function is graphed below. Fill in the form regarding the features of this graph. Okay, so now, since we have, this is going to, since the left side, or one side is going to positive infinity, one's going to negative infinity. They're going in opposite directions at the arrows. That tells us that's an odd degree. All right, now, since it is rising on the left, falling on the right, then this tells me it's a negative leading coefficient. Just the fact that it rises on the right, falls on the left. Okay, so the leading coefficient is negative. Different real zeros, you got 1, 2, 3, 4. That's just a double root, but that doesn't matter. Still distinct or a different zero. 1, 2, 3, 4. So there's 4 different real zeros, and we're looking for relative maximum. So here's a maximum here, here's a maximum here. So that's a max, that's a max. So you have 2 relative max. So that would be your answer. Okay. All right. Okay. Same kind of problem. Now we are going down on the left side, going up on the right side. So we're going in opposite directions. So I know that's odd because it's going in opposite directions on your end behavior. The leading coefficient, remember, if it falls left, and rises right or goes to infinity on the right, that is a positive leading coefficient. Okay, so your leading coefficient is positive. There are 1, 2, 3, 4, 5 different real zeros. Real zeros, remember, are x-intercepts. And as far as minimums go, you got 1, 2, 3 relative minimums. Okay, so 1, 2, 3, 3 relative minimums. So that'd be your answer. Okay. Once again, going in the opposite directions here on your end behavior. So that depicts a odd degree function. And the leading coefficient is positive simply because it rises right and falls left. Zeros, 1, 2, 3, 4, 5, 6 zeros. All right. And then minimums, we have 1, 2, 3 minimums. Okay, so 1, 2, 3, 3 minimums. So that would be the answer for that one. Okay. Now, the graph of f of x is shown below. What are all the real zeros, real solutions of f of x equals 0? Guys, you just listen the x-intercepts here. So I got 4 of them all together. So x equals -7, x equals -6, x equals -2, and x equals 0. So all you're looking for there is your x-intercepts. -7, -6, -2, and 0. All right, same thing here. I got one at -7. X equals -5. X equals 0. X equals 4. So if you're looking at these type of problems, what are the real solutions of f of x equals 0? You're just looking for x-intercepts. So -7, -5, I got them listed out here. X equals 0 and x equals 4. All right. So same thing here. We got x equals -6, x equals 0, and x equals 8. Okay, so what are the real solutions? There's your 3 real solutions there. Okay. All right. Okay. Factor define all x-intercepts of a function. Now what we're going to do here, I would put this in Desmos. That make it easier for you. May have to take a little bit of figuring out, but not too bad. So all you're doing here, y equals -10 x squared plus 4x. Find all the x-intercepts. So I know one of them is x equals 0. All right, now, if you take this number over here and delete some of it, it'll give you a fraction bar. That's 2/5. So you really don't necessarily have to factor it if it doesn't need to be factored. But you can just get those straight off Desmos. This one here may have to be factored. Let me see what it gives us, and then that'll tell us what we need to really do. So y equals, just plug this in. I don't want to do that. Trying, I guess that's all we have then. Okay, well, we'll take that. Okay, so we've got, it just got multiple roots at 0, that's what it is. Okay, so find all the x-intercepts. Guys, it looks like we only have two here. So x equals 0. So there's my 2 x-intercepts. Like I said, if you put it in there, then and it gives you that, then you're good. I didn't see any other ones. If you would factor this, you would have to factor an x cubed out. That would give you 4x cubed minus 3x squared minus 100x minus 75. And then, of course, that's where your 0 came from, x cubed. Set it equal to 0 since it's got a variable in it. Take the cube root of both sides. Alright, so I'm going to go ahead and knock that one out. That's where that one came from. Now take this and group it together. If I can take an x squared out here. If I take an x squared out here, that leaves me with 4x minus 3. And then if I take the sine of my third term, the GCF here is a 25. Wait a minute, I got a negative. Let's see. I should have maybe took a negative out. Yeah, I see where I messed up. Let me go back up here for a second. I should have took a negative x cube out instead, because my leading term was negative. Okay, so negative. Now, if I take a negative out, what it's going to do is change all the signs of these. So that's going to be 4x cubed plus 3x squared plus 100x. Let's see, plus 75. Okay. So what I did, instead of taking just an x cubed out, I took a negative x cubed. Now that's going to change the signs of each term, which it just turns them all positive since they're all negative. All right, now negative x cubed, that's still going to give me 0, so that's gone. And then if I group these together, it's still going to be, I can take an x squared out here, which will give me 4x plus 3. That's going to change that to a plus now, so that's why it's going to give me an imaginary solution. Plus, and then a 25. GCF between this is 25. That gives me 4x plus 3. That's what it is. Now, these are the same, so that tells me they're right. There's a negative 3/4. It's this guy right here. Now, if you do x squared plus 25 equals 0, if you minus 25, well, automatically you're getting ready to take the square root of a negative number. So you know that's an imaginary solution. That one ends up being x equals plus or minus 5i. Don't worry too much about this. We'll go into this a little bit more in part B of this unit. But that would be, so you just got a cube root at 0. Okay, so that's 1, 2. So 1, 2. Yeah, you got a cube root at 0. Okay, so but you usually only look for x-intercepts. This would not be an x-intercept, so not really worried about that. Okay, so going on to the next one. using Desmos, let's see, 4x cubed plus 12x squared plus 9x. Okay, so pretty simple one here. You got to double root it -1/2 or -1.5. So x equals -1.5. As a decimal, that would, or a fraction, maybe -3/2. Okay, and then you got 1 at x equals 0. So that would be your two x-intercepts there. All right. Which equation choice could represent the graph shown below? Okay, so now guys, first of all, that's a single root. Now, if I change the solution or the root to a factor, if you've been paying attention in class, you should know how to do this. It's just x, drop your equal sign, change the sign of the number you have, so make it a +3. That's a single root. Now you got this guy right here. That's x equals 8. So that would be x minus 8. But since it touches the x-axis but doesn't cross, that gives me a double root, which makes it squared, or x minus 8 times x minus 8, because it's double root. And you know that double root just touches. It doesn't cross. Okay, so you're looking for this and this and these two in the same. It looks like your answer there is going to be B. So single root of x plus 3, double root of x minus 8, since the solution is x equals 8. So that would be your solution. Okay. Should be getting near the end here. Okay. All right. We got one at x equals -8, which that implies the factor is x plus 8. Since it touches and doesn't cross, that's a square, a double root. So that means x plus 8 times x plus 8 would be the factor for that one. This or this will be the same. And then you got this guy, that's x equals 2, crosses at 2. The factor for that would be x minus 2. So you're looking for something, the answer with this combination in it. It's actually going to be 8, x minus 2 times x plus 8 times x plus 8. All right. Pretty simple questions there, if you know what a double root is. Now, these are all single roots, okay? So no, all these cross, no just touching and bouncing off. So that's x equals -4. So that's x plus 4. X equals -2. That makes it x plus 2. And then x equals 1. That gives me x minus 1. Okay. So this is my combination: x plus 4, x plus 2, x minus 1. All right, so it's actually going to be this one: x plus 2, x plus 4, x minus 1. Yeah. So C would be the final answer there. Okay. All right, guys. Factoring a trinomial. Guys, just put these in a calculator. That's what the whole goal is, to get you very used to Desmos. if I'm factoring this, all I'm going to do is put it in Desmos. You should be able to get these whether if they're decimals or not. Okay, so now if I put this in Desmos, that gives me so we know this one's x plus 6. All right, now if you change this to a fraction, you should know how to do that. If you don't, I can answer that question for you. This would be, well, now if you make out a factor, that's x plus 3 over 2. Bring it up to the front, so 2x plus 3. Okay, so what I did was I made it x equals -3. These are equivalent, by the way. Then I made it x plus 3 over 2, brought the 2 up to the front and made it 2x plus 3. So this would be 2x plus 3 times x plus 6. Okay. The only hard part about that is getting the equivalent, but on this one, all you really have to do is bring it over to the side, to the bar over here. There's x equals -3/2, right? That's that part. Change it to a factor, and then bring the denominator up to the front. Very, very simple process. So going to the next one, 3x squared plus 16x plus 21. Okay, so I know it's x equals -3. Now here's one that's got a repeating decimal, so I'm going to show you how to do that. I showed you guys earlier, but sometimes it's easy to forget stuff. All right, so if I take this and make a factor out of this is easy. That's x plus 3. This guy here, let me show you how to do it real quick. Let it export it to the expression list, and then take this down. Now, if you look at it and the fraction looks funny, which that's not something we can use. What you're going to do here is take and just keep mashing 3, because that's 3 repeating, until you see the division bar, the fraction bar to the left disappear. Then keep mashing 3 until it reappears. There you go. So what that's saying is, since it knows it's repeating, this is its fractional equivalent. So this is actually x equals -7 over 3. All right, so if I make that a factor, x plus 7 over 3, bring the x up to the front, 3x plus 7. And another way to check this, I mean, if you want to, and this is something we're going to get more into in the rational unit, if you do x plus 3 times 3x plus 7, notice the graphs match. That's the same graph. So what that means is the graph you put in, the original, and the factored form of it matches, which means it's the same graph, so that means it's right. That's a way of checking it. Very powerful. Desmos is a very powerful tool. I mean, it can really make stuff a whole lot easier. All right. Guys, let's see, well, I'll go ahead and do this. Let me see how many minutes I've been going here. Oh, Lord, 49 minutes. Okay. I'm going to skip number 40 for time's sake. I'm going to do 2 of these. This video is getting kind of long. Okay, so I know this is x equals -4. I know this is x equals +6. Both single roots because they cross. Okay, this is going to be one where you have to write the whole equation. You can't choose the equation. You got to write it yourself. So it's going to have a box here with probably f of x or something like that in it. And then now what you're going to do here is do it like you normally do. You're going to bring x equals -4 and x equals 6. Write their factor. So, and then get your y-intercept. So you know you're going to get the y-intercept if there's a blank. If you got to write it, there's no multiple choice answers available. So now this is 0, 60. That's the y-intercept. Now, so what you're going to do, you're going to do y equals a times your factors, x plus 4, x minus 6. Okay. And you're going to take the y-intercept that they give you, which is 0, 6. We found out just a minute on the graph. You're going to put the y here for y. A, you don't plug anything in for a yet. You got to solve for that. You put 0 in for x. And then what happens here is 60 equals a. All right. And then that's 60. Now, if you multiply this together, that's going to give you negative 24, okay? And then divide by negative 24. Okay, now, if you don't know what the decimal, if you don't know how to reduce this, just put 60 divided by negative 24. Negative 5 over 2. And see, that matches, that's going to be your a value. So what that means is right here where the a value was missing, you're going to put that a value there now. So it's going to be negative 5 over 2 x plus 4 x minus 6. Now if you want to, I mean, you can go back. I mean, if it was me and it was my test, I would definitely do it. See if you put this in, does it match do you have the same x-intercepts and the same y-intercept? So y equals, and one good thing, you ain't got to worry about putting it in a different form other than factors, so you ain't got to worry about trying to multiply it out or anything like that. Okay, negative 4, that looks good. Positive 6, that looks good. And now if we get up here and we got a 0, 60, there you go. That tells you that's right. If that doesn't match, then something's wrong with your equation somewhere. It's probably where you plugged it in. I mean, guys, these ain't, if you've been paying attention, you know these can't be wrong. I mean, that's a given. But it's probably your a value's wrong. Maybe go back and redo your math on it and see what's wrong. All right. All right, I'm gonna do this last one. I'm gonna cut the video off. Now, so we know this is x equals 3. We know the factor is x minus 3, but since it touches and doesn't cross, that's a double root. Make sure you know what a double root is. So that means that's going to be x minus 3 squared, or twice, right? And then this guy, that's a single root. That's x equals negative 5. So that means its factor is x plus 5. Single root, so just one time. Because it crosses, right? So now, I'm going to write this in its equivalent, x minus 3 squared. These are the same thing, of course. Y-intercept is 0, 30. 0, 30. All right, so now let's write that in. So y equals a x minus 3 squared times x plus 5, and then y-intercept is 0, 30. So 30 equals a. Don't ever plug anything in for a. You got to solve for that. Don't forget that. All right, so that's 30. I'm gonna do this by hand. So a negative 3 squared. Now guys, don't forget, if you gotta make sure you put those squared numbers in parentheses with a square on the outside. If you don't, that'll mess your answer up. Okay, so a so that would be 30 equals 45a. And then if I divide, that'll give me a equals 30 over 45, which is a equals 2/3. You reduce that down. Now, so my answer there is going to be, I might run myself out of room here, right on the side here. It's going to be y equals 2/3. And remember, we're just going back here and plugging the a in. X minus 3 squared, x plus 5. And then if that's your answer, once again, you could go plug that in and see if it matches your graph. All right. I'll do that real quick. So it should match your graph just like you see it. So y equals 2/3 x minus 3, x minus 3 squared, x plus 5, x 5. All right, there's my y-intercept. There is my -5. It's just, this is just not, you can blow it up a little bit. It's just a different window. 3, -5, that looks good. Double root at 3, and a y-intercept at -30, or +30. All right, guys, that's the whole test. Everything, there's going to be some review on there, but we'll talk about that during the review. There's going to be probably some inverse, absolute value, or some logarithm stuff on there, but we'll talk more about that when the test comes. Hope this video helps. Y'all have a good day. Bye.